Hello, everyone. My name is Brian, and this is the Labelbox Webcast. Today, we are speaking with Gareth Jones. Gareth is a machine learning engineer at Arturo. In the webcast today, we'll cover a few topics and many more. Firstly, we'll cover how Arturo's machine learning team has built mature and complex AI-first products while juggling resource costs, data labeling, and scalability as top priorities. We will cover Arturo's ML workflow, both past and present, as well as discuss how the future of ML workflows may look. And we'll also cover how smaller AI teams can build compelling AI-driven products and services by leveraging their training data and iterating closely with their customers. We'll also cover many more topics. Gareth, welcome to the Labelbox Webcast. Thanks for joining us.
Yeah, thanks for having me on here. I'm excited to talk about, what we've been doing at Arturo over the last few years.
Okay, let's get started. I briefly touched on Arturo, but help us understand, what does Arturo do?
Yeah, so Arturo is a spin out of American Family Insurance, one of the largest insurance carriers in the United States. We started as kind of internal R&D project there to use satellite, aerial, and ground level imagery to provide the most accurate property features available. So our customers will send us an address, and then we'll respond, in under 5 seconds with, 60 plus features using 15 or more deployed models that are in production right now. And, our customers are using that for underwriting, for quoting, for risk adjustment, things like that. And to kind of give it a scope of how large of a market that is, there's about 200 million properties in the United States alone, and about 30% of those go through some sort of quoting risk assessment process every year. So, the size and scale of what we're trying to accomplish at Arturo is quite large.
Wow. So we're talking about tens of millions, upwards of 50 to 70 million addresses being quoted in the insurance industry every year and needing this kind of information that Arturo is deriving from computer vision and deep learning.
Mm-hmm.
Wow.
Yeah, it's quite a challenging task, and we're actually moving now into Australia, so we're on 2 continents and kind of planning our growth beyond that as well. So it's pretty kind of exciting time to be there.
Yeah. Now, could you share a bit more about what your role is at Arturo?
Yeah, so I'm on the machine learning team. So at Arturo, we're very much like a practical and like product focused team. No one on our team has a PhD or any crazy research background. We're very much practitioners. So we work very closely with people on our product team or in our sales team to kind of work with customers and develop products. So as part of that life cycle, it comes to scoping whether or not a task can be solved with computer vision, figuring out how we're going to label it, working with our labeling teams, developing instructions, building training models, and figuring out once a model is deployed, how we can continue to improve performance and provide even more value.
Mm-hmm. Seeing as now Arturo has 10 to 15 deployed models, talk us through how you would size up a problem for a machine learning effort. And in that sizing, how would you create a higher chance of success?
Yeah. I kind of joke that the first thing you need to do is physically look at lots of images. It's no lie that everyone on our team is very involved in labeling the data themselves. So you get a really great sense of, what can you see? And I think it's very common for people to overestimate the intelligence of computer vision, machine learning in general. Not to say that it can't do really incredible things, but I try to approach any new kind of problem saying can I, without any background knowledge of the world, really visually tell if this thing is detectable, and that's a really great starting point to work from. And then the next piece is kind of goes into can I teach a labeler who may not have the same kind of cultural context that I do is it going to be scalable or cost efficient to label this feature given the value that a customer thinks they're going to derive from it? So there's this kind of, play between labeling and value and kind of like some of these modeling aspects as well that really help like set up a problem for success.
And in sizing up these problems, talk more about, you're looking at the data, you're seeing, okay, can I as a human discern the features here and make reasonable, reliable decisions about objects or classification? How does that transfer into a modeling context?
Yeah, so when we're building out this particular model, it obviously starts with really high quality training data, right? So if I can discern these things with really high frequency, we become pretty confident that there are certain modeling approaches, whether it be classification or segmentation or some instance aware model, that it'll be able to like match that human level performance quite effectively. And this is where I talk about not necessarily needing a team of PhDs all the time to kind of prove out the viability of a machine learning product. Like the models that are publicly available thanks to like research done at Google and Netflix, Uber, whatever it may be, provides us a really strong baseline for translating, when you have high quality labels, into a product or machine learning replicate the same quality that label data to begin with.
Got it. That makes sense. And, Arturo's been at this for some time. Talk about maybe how Arturo started. What tools and workflows did you have in the early days, and where are you now? Take us through that journey.
Yeah, so I would say the biggest thing is the absence of many of those things. There is definitely a lot to be learned about, and I think this is why machine learning and why I came to Arturo was such an exciting thing, because most of the big companies that engage in machine learning are these big, huge tech companies that have this phenomenal infrastructure, teams that build and manage all these different pieces for them. But for us, it was like, starting as an internal R&D project and building up all of these different tools, processes, etc., from the very beginning. And to describe the very beginning, it was, people's random S3 buckets storing data using open source tools like LabelMe, then moving towards paid services like Crowdflower, which is now Figure 8, and Scale.ai. But it was kind of a free for all, and there was no organization or process for figuring out when you want to solve a machine learning problem, like making sure that you have the right tools and the right team members and processes to get you that like high quality data and get you that final result as a data scientist. Because we make sure that we give a lot of our data scientists the kind of wherewithal and the authority to be successful, but they need the tools to also like go and build those models.
Got it. In this past world, you had a lot of different tools. You had open source tools, buckets, etc. How was all that stitched together?
Yeah, that was a bit of a nightmare, and partially why that kind of disorganization was one of the reasons we moved to Labelbox. And when you have 6 great machine learning engineers or whatever working on projects without any sort of tools or processes to tie them together, things kind of get lost. And training data is an extremely valuable asset to our company, so it's not really acceptable if you're spending a huge chunk of your company's budget on labeling and it's being handled in sort of open source tools you're not managing particularly well, or services that you're paying for but are having trouble communicating with. And the Labelbox piece was great because from the very beginning there was a very accessible API, and that allowed us to really work to build custom tools and processes around Labelbox, that some of them are pieces of your product now, but that we had internal ideas about how we can improve labeling, et cetera, and have these like consistent data pipelines or tools for monitoring labelers that we built on top Labelbox platform and make sure it was warehoused in a safe place, that it was easy for data scientists to look at it and monitor, et cetera. And so that was a really big turning point for us, is treating labels as this critical piece of our business that deserved, the best tooling available, rather than just being something that was, could be thrown away as soon as a model was built, or, as soon as, we've satisfied some specific customer request.
Right. And zooming back a little bit, you're talking about a little bit of the tool chain. What does that tool chain look like at Arturo? I mean, obviously you have some satellite and other aerial data ingesting into the company, into a storage system of some kind. It's processed, moved into a training data environment of some kind, I imagine. And then there's a modeling environment. Talk about that landscape a little bit. Like how do we put the pieces together?
Yeah. So, as I spoke earlier, we rely on, I would say 90% of our models in production are running on aerial imagery. So the stuff that you see through Google Maps style, when you look down, you see, high resolution picture, and that imagery covers a huge chunk of the United States these days. And, we'll collect imagery for a labeling tasks, huge sample of the United States, for example. And then, we'll make sure that every piece of imagery is uniquely identifiable in our system. And this is really critical. As I'll talk about later, hopefully, about, when you're building these really complex models and have all these models in production, it's really great to be able to tie things back together. So we make sure that all of our data is uniquely identifiable inside of our system. It then gets uploaded into Labelbox. And, before we start any of the labeling, it's like really critical to, have this toolkit for like, how do we build instructions for labelers? What are labelers going to see, et cetera. And so, we'll be like tightly integrated on, labeling performance, using tools to monitor how effective we think labelers are being as they're going through a task. But, another really critical part is, once data is finished in Labelbox, or, kind of at a stage where we're ready to start trying to build models with it, we'll use a custom set of tools built around Labelbox. So we have our own custom Python SDK that plugs in and allows us to use kind of very standardized pipelines, so that data scientists can kind of get their first iteration done, rather than, in 2 weeks and a few days. And that includes the model training time. So for the actual model development, et cetera, we're almost exclusively using TensorFlow. That was sort of a choice to help reduce the complexity of the system. We recognize that there are many successful models and tools built on PyTorch or other tools, but it really helped us focus our efforts on reducing the complexity of our whole system by using one tool like TensorFlow. And then model training is handled using Kubeflow on Kubernetes. So we kind of have large distributed models during training as well, which is really powerful.
Got it. So you started early days, a couple of weeks of per iteration, which is quite lengthy, and from our data is basically the industry average. Now you're down to a couple of days. That's incredible with all the work that you laid out. What's the future look like?
Yeah. So, actually just to kind of give like a recent, thing, we just moved to Australia. So you can imagine that was a pretty large undertaking. It was a new imagery provider, new kind of data domain. So, Australians, it turns out, have way more solar panels, and their cities are way more densely built. There doesn't seem to be permit laws in Sydney, as far as I can tell. So it was a very complicated and kind of like terrifying task, to be like, can you guys in 4 to 5 weeks roll out a huge chunk of our product to a new country, right? So that involved really taking everything that we had built up to that point and turning around faster than we ever had before. So, in that 4 to 5 weeks, we're talking about labeling thousands of images. I think we ended up labeling 20 plus classes or 30 plus classes. So that means rapidly expanding our labeling workforce, making sure that as soon as, training data was done, that we were training models, because a model could still take 3 days to train at a minimum. So, you're kind of like looking at how can you shave off this time right away, and labeling being one of those big time components. and being right on top of the QC and everything like that really allowed us to roll out a product in 5 to 6 weeks that previously took us 9 months to a year, I would say, or more, to like reach a similar level when we were just getting started as a company. So that was a really exciting kind of like view into like what might be possible in the future.
Yeah, that's incredible.
For us and for companies in general, I think.
Mm-hmm. So you have an operating production system in the U.S. You have big, iconic company, customers in the U.S. You're moving into Australia. You do have this tight timeline, obviously, that you work towards. You have a huge set of data and production scale and proficiency in the United States. You're finding there are differences in Australia. You're finding that some of the features don't look the same, aren't beholden to the same laws or rules or what have you. How do you approach that? You have a set of data. Are you trying to find the intersection of the data between the United States and Australia in this case? Are you starting from scratch? Like, how does you and the team kind of approach this problem where you're expanding or entering a new environment?
Yeah, so that was one of our first, really aggressively trying to use model pre-training as a strategy for a number of reasons, to improve performance and to shorten training time, because a fully trained, mask CNN, which is a classic kind of instance segmentation model, from scratch can take up to a week to train on 4 GPUs running simultaneously. So you're talking about, phenomenal amount of compute, a huge amount of just time, right, and money to spend on training. So actually in that time, for those Australian models, we had 3 layers of pre-training on top of it, where we had an old kind of original data set, our US kind of gold standard data set, and then this kind of new Australian data set, which was only 10% the size of or even I think less than 10% the size of our US data set. So that cut down training from 7 days to 3 days, cut down the amount of training data by 10%. And I think it was exciting to kind of like bring in these new data sources, because when we talk about concerns in the machine learning industry and like what people are worried about, when they're building a new technology, is how much training data am I going to need?
Right.
If I have to, expand my product to a new place, like how much time is it going to take for me to label, and build out? Is it going to be start from scratch every single time? And that just doesn't have the scalability that people are hoping, I think, for their own products.
Got it. So now you've got 2 countries you're operating in and a growing complexity of features, regions, and operation, both in software, I imagine, and in your machine learning and training data warehousing.
Yeah.
How is the team managing all of this complexity?
Yeah, so I would say the roles have definitely started to kind of like break apart a little bit. And just to talk about the interaction that we have with the labeling workforce and the machine learning team, very specifically, obviously our engineering team has grown the complexity of our product to a really phenomenal amount using Kubernetes, multi-zone deployments, all that sort of stuff. But just on the machine learning side of things, we really, since the beginning, have been wearing like all the hats, customer, product, to labeling, to deployment, to kind of like the feedback from the model. And that has been great. But the second kind of piece to that is, things fall through the cracks. And labeling is one of the things that easily falls through the cracks, because nobody who wants to be building deep learning or computer vision models wants to spend their time QCing labels. So the first big thing that we addressed, and honestly, we've had the entire company, CEO, CTO, the entire team go through and sit down and label before, just to get, in these hour-long sessions when we were getting started, just to kind of impress on people, how important it is.
Right.
But we started, where data scientists were very much either labeling their own data in some cases. There were models that we had that were entirely labeled by the machine learning team. And I don't think that's like the worst thing to start out with if you're building a product, is making sure that your machine learning engineers are these kind of domain experts or experts in the data they're dealing with. So it was really powerful for people to have that experience and kind of appreciate the complexity of what was going on. But then we sort of grew the team. We added, Lauren, who managed kind of our operations and, helped us find the right tools. And then Sergio, a member of our team who was originally actually a labeler. We had a team of labelers in Chicago that came into the office every day and worked with us directly. But, we decided that we needed to scale up our workforce rather substantially to meet our product expectations. So, we now employ, in some cases, between 30 and 50 labelers, depending on the demand that we have. So Sergio actually rose up from being this labeler. He was just killer at it, and he became the manager for our labeling team. And having that role is really critical because it's somebody who takes a lot of pride in the quality of the data that they're producing. They can be super focused on communicating with the labeling workforce that we use through Labelbox, kind of like actually building up a very personal relationship with our labeling teams, and then coming to a strong appreciation about what's going to be successful, how to communicate labeling instructions, whatever it may be, so that when I have a particular task, I can come up with how I think it should be labeled. I can work with Sergio, build out full instructions, 10 or 20 page PDFs describing all these different failure cases, things they might get wrong. Being aware of the cultural context of our labelers, like we had an issue where, RVs are not particularly common where our labelers are based. And so they just thought they were sheds all the time. So we had to kind of go through and be like, for any person in the United States, this would have been like a trivial thing. It's like you've seen the people who have like massive RVs parked in their driveway, and there is just not the same appreciation. And you had to be aware of that. But if you screw that up, that could cost you days of labeling, especially if you're on a tight deadline or trying to roll out a new product or being cost efficient. You can't afford to make these big mistakes that cost you days or weeks and 30 people's time, for days and days. So making sure to like really have that high marginal value, it's really important that you have somebody that takes pride in the data, communicates well with your machine learning team, so that machine learning engineers can focus on building that kind of like early model development, early like research ideas while the training data is getting labeled, and they don't need to be sucked into that as much. That's not to say that I still don't occasionally label like very hard things. Like I think every single solar panel in our data set I have personally checked off as being a solar panel. Not that I'm even a perfect labeler, but it says a lot about how critical that process is to the company.
Right. Well, it sounds like there's been a meaningful evolution of the labeling practice and the operation and the team cross-functional setup. Having all those lessons learned and mistakes made, how would you describe kind of the ideal interplay and team members, so to speak, or functions that are necessary or you suggest for having a strong data labeling operation? Meaning, you talked about you're coming up with instructions based on the business needs and objectives of the model, so forth. That converts into a training data development process through this interplay you discussed about. Today, starting fresh, like what are the elementary components here that people can take away and put to practice?
Yeah, I think, if you're just starting out, like building a machine learning product, or you think you've got a great idea about something that could be solved with machine learning, the first piece is getting people that are, willing to like really hack through problems. They don't need to be a PhD in, computer science, having like published papers or something like that. You can start out with people who are just really interested in the field, who are good engineers, who can help you develop and build that product. Label yourself in some capacity. And I think that's why we spun out successfully, was because that was kind of the internal mindset. If I was to go back and say, what should we have done next, after that internal sort of success, the next piece would have been like, find your Sergio and Lauren and these other operations people who can prize the data like right away and like create and maintain a lot of value in the organization for that. And, there's different machine learning products that may have different sort of relationships with their training data, but, for computer vision, it's a huge effort, really great rewards, but it needs to be, treated, right away. And then Now, I think as you grow the team and you kind of have this more maturity, having data engineers that can make sure your pipelines out of tools like Labelbox are working, don't have any bugs in them, really owning the kind of the movement of data around a bit more. And then your machine learning engineers can focus on deploying and training models. And then only at the very end would I say it's like really necessary to hire maybe some of these dedicated research staff, that we see these large companies having. I mean, it's a very expensive skill. It's very rare, but it could provide a huge benefit for you. But it's unlikely probably to be the thing that makes or breaks the success of your machine learning product is that research scientist. So I kind of view that as, if you have to go to the well that far to make your machine learning product work, you're probably going to have a lot of trouble building a successful product that really scales quite well.
Having met both Sergio and Lauren, I know their impact, and it's taught myself and in our group a lot about the importance of that role. How do we illuminate and elevate those folks, generally speaking, and their importance to organizations across, different AI teams around the world?
Yeah, I think it is like, I think people frequently, we're talking about, employing 30 kind of what I think people would traditionally consider like low skill workers to do labeling, which I think is a really disingenuous thing to kind of say, because if you label enough data yourself, you'll realize that this is not an easy job, that a lot goes into this, that like even, people like Sergio and I make mistakes frequently on, labeling data, et cetera. So there needs to be really kind of more human understanding of the people that work in doing this labeling job. I think frequently we just think of farms of people doing this like monotonous task to make these systems work, and appreciating what goes into that is definitely the critical thing to taking roles that Sergio and Lauren have seriously, that these are people that are working for us, if so even indirectly, and that we need to make sure that we're giving them the tools to be successful as well. And if you are ignoring that component of the job or of the process for building machine learning models, you're unlikely to be successful. So, really not hiding the people that make these products successful from view and from like the minds of your team is really critical. So making sure that communication and understanding of what this product is going through, like what these people are doing is critical. I mean, when COVID started, we initially had a big hiccup, for like a day or two where we were like freaking out, like, what is the situation going to be if we have all these labelers and they're no longer able to have access to their offices or to have high-speed internet, they're working from home. So we needed to start thinking about like, just simple things like, can we make instructions be like smaller? Like, sometimes we'd accidentally ship instructions that were like 1.5 gigs because we wouldn't compress the images that we had like pasted in PowerPoints. And like, this just doesn't work, right? Somebody who's labeling can't, who has a poor internet connection, just no way they're going to be able to get our instructions. So, there's just little things like that appreciate the situation and like who you're working with. And I think, Labelbox is also a great example of that. We know that Labelbox works with our labelers to make sure that the labeling platform runs well on their computers, which are less powerful than, the MacBook Pro a developer is working with here in the United States.
Got it. Touching on our last topic here that I'm really excited to learn more about, and I think the industry is excited to learn more about, is how did Arturo and other smaller companies who have limited budgets with limited team sizes, what's the recipe for success against you have large incumbents out there and you have a general sentiment creeping in the broader industry, which is, data is king. And I think we agree with that sort of philosophically, but, large incumbents are labeling, millions and billions of data points and see that as a competitive advantage and tout that as kind of the end all be all to some extent. How does an Arturo or a company like yours with a small team and a limited budget succeed? What's that recipe?
Yeah, it is definitely, when you think about like really who are the companies doing machine learning in the world, it's, FANG companies. It's really traditionally been something that's largely reserved for the huge companies in tech. And, you know, when we look at our trajectory and kind of like the future for what's available there in tech for us to kind of for small companies to be successful, I mean, like Labelbox is a great example of that, where we're really excited to see these tools that could make a small team successful really grow, right? So if we look back 3 years ago, the number of tools that could make a small company successful were way fewer, right? Like we know that many companies for a long time brought their own labeling tools to our workforce, right? So you would have to build and maintain your own labeling software, which is when you're trying to build a labeling, a machine learning company, like the last thing you want to do is build your own labeling tool. Like I couldn't imagine having, 2 or 3 people, dedicated to produce a low quality polygon labeling tool for us. We just wouldn't have the ability to be successful. So I think there's, aspects of, companies coming in and serving smaller companies like us with really high quality tools that makes it possible for people like us to succeed. I think there's also some really great research coming out about how to do machine learning practically, and how can you solve machine learning problems with not necessarily less training data, but how do you get more value out of every piece of training data that you work to collect as well. And that is, a big part of our kind of like future, hypothesis a bit about what we can do on the modeling side and on the labeling side to be more successful on that, because our system has grown to be very complex.
Right. And clearly, there's a lot of large insurance companies out there that you work with and use your product. They clearly have big budgets. They clearly have the, in theory, the ability to go and do this work.
Yeah.
And likely able to collect more data and potentially, like, in simplistic terms, label more data than your team. What I do know a little bit about Arturo, and you guys have a relentless focus on the problem and working closely with the customer, similar to how a software startup would work, kind of in an ML side. Talk more about that. Like, what's going on there, and how is that getting you this marginal uplift on data and model performance?
Yeah, and I think I don't want to describe it as like different waves of like the machine learning AI revolution of like, if we look back a few years, the big thing was just like massive data sets that, companies were talking about, needing these like cloud scale data sets of, billions and billions of rows. But I think we've seen that can be very effective, but that it's not simply enough to have, huge amounts of data by any means. Yeah, we're dealing with insurance companies that have data about millions of homes in the United States, but they're clearly struggling to get high quality data. They're clearly struggling about how to be nimble and efficient in building models. And I think like a small company like us has like had a lot of really critical learnings about how to label data, like kind of gotchas that it would be hard for a large company that just assumed they could spend $1 million every month on labeling or something like that and just performance would just be totally caught up in. And, it's not to say that some company couldn't develop some very nimble, kind of like efficient and kind of hack together sort of team sometimes, but it really benefits us being smaller and being more agile to like think about like, okay, come to a new way of doing this sort of thing, being able to work with our executives and our product team to be like, we were doing things this way, let's do a switch, and like, consider labeling things differently or try a different modeling approach, think about how many different models we're deploying and stuff like that.
Got it. Yeah, it's really interesting. Well, Gareth, thank you for sharing and answering questions with me. I've learned a lot. Thank you. We
Thanks.
do have some questions from the folks here joining with us. And I want to start with one from Loretta. They ask, what are the sizes of the different data sets you're using for model training?
Yeah, so it's, without divulging too much, it's a little complicated because there's sort of a balance, like the size of the data that we get labeled versus the size of the data we train on. So in our example, we will frequently pull very large areas to get labeled, but kind of slice them up into smaller data sets, or make them larger data sets by cutting up the images in particular ways that is advantageous to our models. I'd say it's probably, on the order of, I don't think it can kind of like, and this is one of the really interesting things about, how large of it, this is a big question, like how large of a data set do you need to be successful? And I
Right.
think we're very fortunate because you've got to think about like how complicated your image or input data is, right? Like if you had to build a machine learning model that parses any random cell phone photo, like Google frequently has to deal with, like they want to be able to tag, a picture of a bike from like 30 different angles. But for us, it's like we benefit greatly from having a very fixed and constant sort of state. Like everything is the same resolution. So every single image, 1 pixel equals like, 7 centimeters or 6 centimeters or something like that. So our domain is much smaller than some of our competitors, or not necessarily competitors, but people who are doing machine learning, and you can really leverage that to be quite effective in our experience. Where if what you're doing is simple, if the input data is more simple, you can get away with far fewer labels. So sometimes we'll start off a model with only 50 to 100,000 labels, then determine, do we need more? Is it a question of label quality? Is it a question of label quantity? How can we do some augmentation that matches what we're seeing in our production setting much more closely? So there's a few different knobs to turn there to kind of get the data set to the right size. I mean, we found that we've definitely collected too much data in some capacity where we got very little incremental performance after we labeled, some number of images for the particular feature. And we kind of wish that we hadn't bothered to do that. So it's very easy to like label data that's not particularly helpful for building a funnel product.
And on that piece, like how are you, like what's the lessons learned there? You collect too much data, you're seeing marginal improvement maybe in a performance metric. Yeah. Anything more to it than that?
Yeah, so there's kind of like two problems where we sort of like have to handle, and it's that we have like two sort of dependency issues when it comes to labeling and modeling, where we sometimes have to label certain things to be able to label other things. Like if we want to label roof material, we need to label roof panels first. So you kind of got to expend all of this money. So you want to get better at roof material, you got to get more roof panels, even if your roof panel model is like perfect, right?
Right.
And so
right.
you kind of those annoying dependencies that are kind of another form of that is, it's really helpful for labelers to have context. So when we say a solar panel label, we also want to label solar water heaters and solar pool heaters, which are two similar looking things, but slightly different. And so it helps the labelers to kind of have these other classes that we maybe care less about to just give them context. And then a third sort of dependency issue is when we train a model, we find that it's frequently helpful to have labels that describe the remainder of the image. So even if we're building a model that predicts solar panels, we'll frequently include trees in there just to kind of like give the image more context, to be like,
I see.
These pixels are associated with trees. We throw away that inference. Like we don't use, like that model is not supposed to make a tree prediction. We already have another model that does the tree prediction. But the problem is like, you need to collect trees for every single solar panel image. And if you have rare classes like a solar panel, 1 in 100 or 1 in 20 images, depending on where you are in the US, has a solar panel. How do you collect enough solar panels without spending tons of money on detecting trees, which we can crush with only a few thousand examples because trees are super easy to tell. So that kind of comes down to like, how do you model things, and some of the future work that we're excited to see that like Tesla's doing around multitask stuff to kind of like break up those dependencies a little bit so that you don't need to spend as much money on trees if you're already good at trees, and you can spend more money on labeling solar panels, but still get that kind of cross, or model context improvements that we've seen are really great.
Right. And that's kind of part of this getting more value. You add a little more sort of data around what you're looking for, and that um, helps, drive that signal from the noise. We have another question here from Sanjay, who asks, how much time are your data scientists spending cleaning data versus spending on model training? And I imagine just model things in general.
Yeah, modeling things in general. So, because we have people like Sergio, I would say the time that we get to spend on modeling has gone up significantly over time.
Mm-hmm.
The thing is like, if your team is set up in the way that the machine learning engineer, data scientist, however we call them, is responsible for the model, for the outcome of the model, the performance of that model, which isn't necessarily accuracy, some like threshold for accuracy, but delivering some kind of value to the customer, you'll find that if your team is invested in those things, like in that outcome, that they will spend a decent amount of time labeling, or at least enough. They'll figure out what is the right balance to make that successful. Because nobody wants to be doing the labeling. And it's a really great incentive for machine learning engineers to find the Sergio and Lawrence and their company and really kind of elevate that role so that you can kind of dedicate more of your time to that. But I don't think it's worth ignoring because it'll give you a lot of context about the problem that you're trying to solve as well. So I definitely encourage people to take the time.
Still a meaningful amount of time, but the industry, the industry data suggests, 80% or more of these data scientists and ML engineers' time is spent in this data cleaning and potentially even direct data labeling process. Do you think you've, with Sergio and Lauren and the labeling operations function that you've built out, do you think you have more time than 20% for the data scientists and ML engineers to spend on sort of the problem at hand in the AI algorithms and model development?
Yeah. So I think one of the big pieces is like, if we were to talk about like people, say like 80% of data scientist time is ETL. And I would say if you're, computer vision company, it's really like half of that 80% is labeling maybe, and half of 80% of that 80% is the like turn your, export your data from Labelbox and turn it into useful training data for your model in some format that can be consumed during training. Like, I think we've scrunched that 40% for the constructing the final training data, that has been compressed down to, unless you're trying something really exotic, kind of something new, that's probably gone close to zero on our side of things for a lot of like our standard processes.
Wow.
We're doing some like kind of particular things like, estimating heat maps and some things that I've been playing around with. And that required some sort of custom model building. But I mean, we're talking about like even reducing for that to be way smaller, like shared code, not likely to produce errors, things like that really reduce the amount of time you spend on the ETL part of the kind of data engineering piece of the job. And, that's great because, if you're fine with like 50-50 modeling in ETL and you consider that 50% to be more on labeling, you're going to get much better results, I think.
Yeah. That makes sense. Digging into some of the more nitty gritty of labeling, which inevitably we all arrive at, as you mentioned, and really is one of the core elements of success. Jacob asks, how do you manage a hierarchical nature of the labeling and the training data itself, I imagine here? Yeah. For example, roof panel versus roof material.
Yeah, so that is it is complicated. And we actually use our internal tooling to kind of use the API to kind of perform some of these tasks. Like I think if you were in Labelbox, and we've been working with you guys for ages about how do you track maybe features at a global level, which I think we're really excited that you guys are implementing some of this technology to make it so that you can kind of like routinely refine and add more nuance to your labels. Because when look at the initial feature that we started with, we probably had like 10 features or 15, depending on how you like count them, that we labeled. And now we've exploded that number. And it's not necessarily more polygons, it's more subclassifications. So like a panel could have material and slope. And when you bring in 3D data and superimpose those panels, like you get all sorts of stuff. And we tried, like the same way that we try to track our images at like a, internally at a company level, so we can do all sorts of things, about like matching them with geospatial data or whatever it may be. The same thing we kind of want to do with labels. And I think Labelbox's platform is really beginning to empower us to do this more sophisticated tracking. Traditionally, it was about really good management of Labelbox projects and using our SDK to like push labels around in particular ways, kind of like handle this flowing kind of like set of data between different places on our end. But I think we're really excited to see that kind of be considered like a first class thing, is that if you're a data scientist and you're labeling, you're instantly going to be like, oh, I can tell this X more thing about this panel or this object. Like, we now label cars as, trucks, pickup trucks, tractors, all sorts of things like that, boats. And that came from like spending up time. And then we had to reclassify these polygons. So it just takes careful planning, I would say, and the right tools to make it happen.
And what does that process actually look like? You've scoped some problem, you've thought through the model and the ontology and the labeling process, and down the road somewhere you realize, oh, okay, I need more granularity. I need a subclass here. Why does that happen? And how does the team go about kind of making that happen, I guess?
Yeah. So yeah, I mean, sometimes we'll get a customer request that's like a frequent one. Like, we moved to Australia and it turns out asphalt roofs are really not that common because still melt. So like we had like new classes that people love way more like other types of roofs in Australia. And so sometimes it's driven by like a specific customer request where we've got to go and solve that problem for that reason. Another is just kind of, we found that models that have a more descriptive view of the world, and still a very naive description of the world via our labels, but they seem to perform better. It helps us distinguish things quite effectively. So when we, started splitting vehicles up from vehicles and trailer homes and things like that, it helped provide a little more context. And it was like we had some like kind of, extra, labeling time available to us, so we could kind of like go and try out this kind of like feature and, roll it out and either to aid the model in production. So if a trailer, you're not going to keep, mistake it with a shed. So it kind of comes to like, how can we boost performance in that way, and that kind of rationale. Or kind of anticipating some requests as well that we know we'll have.
Got it. Okay, we'll do, I think, one more here, if you're up for it, Gareth.
Yeah, let's do it.
Cool. This one is from Sammy T. What is the biggest pain point in your labeling ops right now? And to that end, what feature hack improvement do you think would or will alleviate it?
Yeah, so trying to think, like the big thing is, as you're, I think we tackled like very easy tasks first, like detect a roof or detect a pool, right? And then you get to like much more complicated things, like how old do you think this roof is? Or is this some like staining on a roof, or is it a shadow? You get to things that become like very nuanced to a person. And remember that, we don't have direct connection frequently with each individual labeler. We have like, direct contact with their labeling manager. So when you have these like really specific, easy to mess up things, it's how do you go and communicate to that specific labeler that seems to have, because only maybe 5 in the 30 labelers actually have an issue with this task. And how do you kind of focus the efforts to make sure that you catch those sort of mistakes or these really challenging problems like early on. And so we've done some stuff with kind of building dashboards and tools for our labeling team so that we can try to proactively identify the like issues that might be cropping up. So we'll collect metrics. How long does it take them to label? how frequently do they find a class in an image, sort of like, doing this kind of like eating our kind of own dog food sort of situation of like, we should be applying data science to the process of our labeling as well. It's not just as any kind of a way to catch these things like earlier on. And we've had some kind of initial success with that. We kind of imagine building out more of those tools and working with Labelbox to make those more successful.
Okay. Thank you, Gareth, very much for joining us.
Yeah, thank you. It was a great conversation.
Yeah, agreed. And thanks to all who joined today. We'll be back soon. So take